we
Yeah,
make this, even drones is there.
that's right.
Mm.
Okay, everybody, we are going to be starting our last and very exciting session of the workshop. And I would like to introduce Dr. Weisong Shi, who is the Associate Dean and Distinguished Faculty Fellow and Professor of Computer Science at Wayne State University. And he is also one of the pioneers of edge computing and the author of a very influential paper right here, that defined the edge computing vision and challenges. And he's going to talk to us today about more challenges that we could solve, hopefully using Chi at Edge. Thank you very much for accepting our invitation.
Thank you, Kate. This is great. I'm so glad to have this. Can you see my screen now? Okay, so then would you mind share the screen?
Yes, I can see your screen.
But it's not on the big enough, right? Okay, now probably it's good, correct?
Yeah. Yes, yes. Now we've got in the presentation mode.
Okay. Thank you. Let me see. I have a point here. All right, good. Well, thank you very much, Kate, for inviting me here, and I'm actually very excited that that to have an opportunity to talk about this, because we are also want to using a community. One of my students in the past 2 years as a student intern at Argonne National Lab, as they are using a community and to do this to do their work. So
that's fantastic to hear. I'm sorry, I had to say that. Always good to meet new communities.
Yeah. So in the next half an hour, I will try to finish as maybe in the 27 minutes, and then that hopefully can take some questions here. So the talk of today is when Katie asked me. So I thought about edge intelligence, because you are this workshop is about Chi at edge. So we thought that it might be good. And then based on my experience, I want to show particularly two potential applications that can benefit from, this architecture. So, okay, next. Okay, so here is a very quick snapshot for this talk. So I will talk about why edge computing, and I think like Kate mentioned, if we back to 5 years ago, it's very important to talk about this. But today, I think that edge has been very commonly being the people putting on their resume, asking, what are you working on? They said that, edge computing. So I think in that case, I could make it a little bit easier. And then I will talk about, edge, what does edge intelligence means to us when we talk about the infrastructure support. And then I will cover these two applications, very high level data that we have been working on. So this figure, I drew that again 5 years ago, so that we think about what is the digital infrastructure. So I think the reason I pick 2005 is because by that time the cloud just getting started. So from 05 to 15, in this 10 years, if you think about the digital infrastructure point of view, is like the key features here is the people collecting all the data, push to the cloud. And I using 3V here, but you can easily extend it to 5V, 7Vs. So you have different volume. People talking about is a PB level, and the data has been changing not very fast. But it's near real time, and etc. The most of the popular programming model here is starting with MapReduce, published in the OSDI, and that's actually perfect time by Jeff Dean when they working on this. If you're looking for from infrastructure point of view, is you guys are expert in this, looking for how healthy of this of the infrastructure, such as community is one of the NSF cloud infrastructure. You probably need to deal with reliability, availability, and etc. So, but most of them is focused on the single data center. And then the sustainability is another issue. People look at the PUE and etc. That was what happened in the 05 to 15. So we're talking about the digital infrastructure. And then if you are interested in this, by 2015 June, we organized a NSF sponsored workshop at Stanford, so that called the Sustainable Data Centers. Thomas Winish on his website, he was a program co-chair at that time, so that regarding what is on the sustainability issues of the data center. And then on the 15, starting from 15, that edge computing becomes emerging, as an interesting research next step. But many people asking that, oh, this is not new, edge computing. However, I agree with that. It's not a new concept, because back to 2000, Akamai and etc. They're already doing this CDN. But the thing is, there is a very important that the two driving force behind this, why edge computing became gradually it became popular back to like 5 years ago. The one is because of the push from the cloud providers that they want to this latency, availability, save bandwidth. Those are the typical reasons. That's why, as of today, you can see many of these edge computing that framework providers, software-wise, Microsoft, Amazon, they're actually pushing very hard on this. That's because of that. There's a need here. So that's why it is we talk about infrastructure 1.0 first, because you move the data there that is not enough for them to continuously provide this kind of experience. And the second is obviously is because of Internet of Things. People are starting putting these cheaper sensors, collecting a lot of data, and then now it's generating more and more data from the IoT side. So IoT also call for that because they call for some computing powers as close as possible to help them to reduce this. So I'm gonna mention this later that for example in the CAV, connected autonomous vehicle, you're gonna generate a huge amount of data and you can't really uploading all these things to the cloud anymore. So this is a figure shows that by 2020, almost 60% of the data generated is coming from the edge now. For example, Gartner is predicted that by 2025, among all the data, 75% of this data is out of the data center. So for example, in Chicago, Argonne National Lab and University of Chicago, you guys have a big project that collecting the smart city project generates these giggles, right? So these giggles, you're putting on this multiple intersections, itself, it generates a huge amount of data. Right now, they are putting GPUs, they're putting ARMs, CPUs there, trying to process, this kind of data. So I think that that's basically is a trend from the architecture point of view. So that goes to digital infrastructure 2.0. Here is we talking about, it's much more bigger than the original cloud computing infrastructure. So the data right now, the volume level is go to ZP level, and then it's a real time, data changing very fast, and you have no way to really send it back. So you better to really process it, as is. And also a variety of the things, even a single sensor, ANL has been developed, the Gigo sensors is including, I think it's probably more than, 10 different type of sensors and temperature. You have temperature, and this is the traditional ones, but you also have the, camera data, look at them, most of them need to be processed in real time. So if you're looking for here, basically is the data now is distributed from cloud edge. And then what are the appropriate processing model here is not very clear, compared with in the cloud era that you have a MapReduce, Spark and continue. Now the people are talking about, CMU developed this CloudNet, my group have developed a Firework, and then recently there's a function as a service. So many of you probably also working in this space. So you need to develop this programming model and etc. But where are you going to run the experiments here? So I think that's why you need to talk to this particular workshop is perfectly that they're going to provide some infrastructure for you to run these things. I still recall in 16 when we do this Firework kind of evaluation, we have to deploy those Intel fog node donated by Intel. We do this by ourselves. But imagine if everybody is doing this, when you're writing a research paper, if you're doing too small, then it's not real. People will challenge you. You are not really doing any edge, and also you don't have even enough data here. So I think Kate, when they contacted me, I think this is a great idea that it's good to have an infrastructure here to support this. If you're interested more on this, in 2016, Mo Chang right now is the Dean of Engineering at Purdue. So he and I, we co-chaired this workshop talking about the challenges on the edge computing. There are interesting things there. You can still, look at them and looking for the, from an infrastructure point of view. And then the health management will be a big challenge to the whoever is maintaining this this infrastructure, because how are you going to be running this with these tiny devices run experiment is going to be a big issue. And then sustainability, when we talk about even energy efficiency, that's also another challenge, but that's probably not the challenge in this workshop right now. So as in the last 5 years, as you can see that edge computing, basically that I draw this figure in the proceedings of IEEE when I do the introduction. So it's most likely people already agree on that. Hey, no matter what type of application you're talking about, you probably it's in the IoT on one side into the different scenarios, and then you have edge, depends. For example, if you have a drones, you have different sensors, body camera data from the police officers, and then the vehicle itself could be a very powerful edge, And then if you're talking about edge, vehicle as a sensor, as an IoT equipment, and then the edge server, then the roadside unit might be an edge. So in this sense, it's still in the original definition that the edge itself is a continuum. It's not like you have one device, this is the edge. That's not the case. So it really depends on what the scenario you are talking about. Basically is you can think about whenever your power, you need more computing powers, and then the next level between you and the sitting between you and the cloud, who can provide some help for you. That could be your edge server, to help you. So I using an example from the Facebook. I pick Facebook as an example that to show you that what's the next digital infrastructure going to look like. So imagine that they have a multiple data centers. I using 4. This doesn't mean they only have 4. Okay. So this is a short example when I give a talk to a Facebook that then they deploy the multiple edge clouds, from to compare with those big data centers, there are edge. And then, when the people is depending on where you are and when the people are moving around, so you will be able to, for example, while you are sitting here, so you sending a request to go to Facebook, you might go through this way. And then later on, when you moving to another places, depending on the accessibility, depending on, that is a requirement and the load balance, and it might be go through the other channels and etc. So those just show you example that how this things is right now has been deployed on the internet. So hopefully this Kai and Edge infrastructure can help us, the research community can using this to mimic this kind of these scenarios. So that would be fantastic. So I will move on to the next part is about the edge intelligence part. So from these 2 words, you can easily tell that okay, basically it's putting the artificial intelligence AI on the edge. That would be the edge intelligence. But I want to show you from a little bit from the point of from the infrastructure point of view that what does this really mean to us. So here is we draw the figure here is basically if you're looking for on the cloud side, you have this 3 tier. You have the hardware, and on top of that you have software packages. And then on top of that, you have intelligent algorithms. Now, when we talk about the edge intelligence, as you can see that first of all, you have a multiple edges, that deploy in multiple places. And then for each of them, pretty much, the hardware you're talking about, each company come with this, small devices of particularly, like edge, for example, Google come with a TPU that's particularly designed for the edge. And then most of these packages today come with a light version, like NVIDIA is pushing for the Tensor RT, TensorFlow Lite, and etc. And then on top of that is either through the quantization or through the pros of the network, the model itself is much smaller. And those is what we're talking about when we're running on this edge intelligence. So from the, so give you a tangible view. And obviously sometimes edge to edge, because you're close enough, you might want to collaboration, for example, in a tracking for the vehicle in the city of Chicago, and then you have the multiple, the node has been deployed on this, so you can leverage this to do the tracking based on these models. So that was the we talking about And here, this figure, I can go quickly to show you that, traditionally, the edge, you connecting data to the cloud, training the model deployed here. But now, because the edge is becoming more and more powerful, and also there's a lot of new things, new data is continuously collected. So that's why the people are starting doing the local training today. You deploy a model, but then you can continuously keep training here to adjust for your needs. And this is basically we think about an infrastructure should be support us to do this collaborative edge intelligence. I will use a couple of examples to show you later that this is very important today. That, for example, in the health domain, people need to do collaborative, multiple locations, and then in the vehicle, obviously that you want this multiple vehicle, even deploy the whole U.S. They want to collaboratively working together to to train the models and etc. So that's basically, sorry, I am a little bit Chinese character here. That was another article that one of my former students recently wrote in there. You can ignore that, but basically this is to show you that collaboration is not just a vertical, even it's a horizontally, it's also have a big view here. And then here is in 2018 on the hot edge. So one of our students has done a paper trying to evaluate that how these models, in terms of different metrics, different devices, and then the package and the models, how are they perform on this different different edge devices. And then we showing that this figure is showing that there's no one size fits all. As you can see that it depends on what you are looking for. For example, if you're looking for total time on this powerful fog node from Intel, there might be Tensor Flow is pretty good. And then if you're looking for some other Jetson TX2 small devices, and then that this MaxNet itself is good. So basically, it's giving you a lot of there's no one can beat all of them. So some of them is good for particular devices and etc. And this is going to give you an idea that if you depend on what type of application and you are talking about, and then you have to make the right choices on which one is good for what. And then sooner, once we're talking to industry people, we realize that it's very important to have a we call the open EI framework, which can help you to select the best the best hardware and software package for you to running to fitting your needs. So basically is we're doing the optimal selection on this, depending on the accuracy requirement, latency requirement, energy requirement, and memory footprint, and etc. So that was the OpenEI framework we have been developed to try to satisfy this. For example, for the water monitoring, for this application scenario, compared with a connected autonomous vehicle, that will be completely different requirements, so that you might want to choose different models and etc. So next, I want to share with you a little bit on that edge computing on the CAV space. So at the Wayne State is located in Detroit. So we are lucky because with the university support, I myself actually built this real autonomous vehicle, because this is itself is not although a vehicle, I can share with you that the vehicle, the price of this vehicle itself, that is only contributed about 1/10 of the total price of this autonomous vehicle. So as you can see that it's very expensive. And however, this gives us a chance to generate the different type of data that we have a lot of, the sensors has been equipped on here. So we can generate whatever data we want, so that we can collecting ourselves, and also we can test our driving, that at the downtown Detroit and etc. So this just to show you example that why CAV is an interesting application is because it's more, you can think about this, it's just a computer on the wheels. From our computer science point of view, it's pretty much you have different sensors, you have to running on different algorithms, and then you need to make decisions. And there's one interesting thing here is it's a physical system. We talk about cyber physical system. It's a physical system. You have to consider the vehicle dynamics. You can't just ask this guy turn 90 degrees immediately, right? Because the vehicle will not be moving there like you want. So you have to really think about this. So given that context, here is our view, our vision on that, the future for this CAV. Each of them have a lot of computing requirements that here, and a lot of data has been generated here, different type of applications, and then they through different communication channels to talking to the different vehicle and also to the roadside unit. And roadside unit also come with their own data. For example, in the traffic light, they might be seeing the other roads which the vehicle itself cannot see. So that's why you need collaborative ways to working together. So here is a vision we call the vehicular computing that it was published a couple of months ago. Here is we imagine that the future, the vehicle, as more and more this autonomous future will be there. So what's the vehicle going to be doing? Vehicle will be there for 24 hours. Assume that the energy is not a big deal. They can always, recharging quickly and etc. Then the vehicle is a mobile computing platform going to be around you. So in this case, you will see not just the vehicle edge server cloud, and also your vehicle can be used to collecting a lot of data. For example, in city of Detroit, we have working with them. There's a van every week is going to be go through all the streets on there, so we can detect any like a fire hydrant and etc. You can collecting this data through this vehicle. So that will be a typical 4-tier vehicle computing paradigm. So if you're interested in working on this, I hope that in the Kai Edge that you can think about the way that how you can support this type of new the computing paradigm. So this is going to be I'm very excited about this vehicle computing. It's going to be completely changed. This is not like the vehicle network. People talking about the communication. We are talking about the computing here. So this will be completely changing the way how today's the way computing is about because of this vehicle things on that platforms. Here is showing very quickly about the research activities happening in our group. So we basically ranging from the benchmark and then to the machine learning operating system and the cloud edge analytics and the communication optimization, etc. So we do quite a lot kind of research on this. And this little stuff, it was developed by our lab 2 years ago, because there's no such things available on the market that can support our. We want to do the autonomous driving research, but then that small scale. So we developed this. So far in the last 2 years, those are all the hardware platforms that developed by my group. So we have this purely autonomous driving, but it's like a robot, but it's for indoor. You can test your algorithms, etc., energy efficiency. We also have this, small outdoor delivery vehicle that we have make this, but allow us to running on slowly. And then the last one was I mentioned earlier that we can do on the highway, even during the regular street. And this is not enough because V2X is very important. We also developed this edge server we call Equinox. That was we're running different type of hardware here. So basically FPGA, GPU, and combine them together. The really cool thing here is this guy is supporting LTE, 5G, DSRC, and most recently a company donated the CV2X to us. So this guy actually can talk into the multiple communication channels that can do this. So with this will be the hardware architecture that hardware infrastructure that can be used to support this research. And then the last thing I want to talk a little bit is about the healthcare. This is if you're working in this field, at least you might heard about that connected health is very important. And if you're looking for that, it's very similar to similar to the traditional compared with a vehicle, because a vehicle is just moving around. But if you think about the health, you also putting the sensors around people, collecting data, and then sending back to the cloud. And then similarly, there is an article interviewing me about a few years ago. There are in this industry they already realize that the edge computing going to transform the healthcare. So that's why there is a lot of interesting discussions here. So what are the benefits here is you can doing a lot of things here. I don't have time, but you probably can easily think about this. You can reduce the efficiency. I want to pick one example. So here is why edge computing can help them to improve the efficiency. So imagine that today in many of these 911, I think I have a slide here to show you that when you call 911, okay, here. So one of the projects we're working with the St. John's Hospital and the Detroit Fire Department is many of these 911s, when you call the people, when this ambulance comes in, bring you to the hospital, many of them is not really in emergency. So that was when I talked to the emergency doctors. So the reason is because there is a gap here. The people, the 911 dispatchers, they have no idea about what's your symptom, right? So now you can think about it easily that if you just a simple bring some of the a camera, for example, take a video of this patient and then just sending back that video directly to the hospital. Now doctors there can just take a quick look and then they can make a decision whether or not you really need to come back to the hospital, etc. So those are the things that, and also many of the the ambulance today that we call the BLS, basic life supporting system. What they are doing itself is quite simple. They just transfer you from your home or from the apartment back to the hospital. But those time is completely wasted. So if you can put in more and all this kind of telemetry, for example, blood pressure, heart, and etc., you can collect data at the same time while you're on the way to the hospital. This information already being transmitted there, so the doctors can be very well prepared. That can be save time, improve the efficiency significantly. So that was one of the things that our group have been working with the hospital before. The other example I want to show you is the last thing is recently one of my former students, we're working with Henry Ford Health System is collaborative learning. So here is, we all know that, most of the health system, they have more than one hospitals. For example, in this case, Henry Ford headquarters is here just next to Wayne State, but they also have 6 other hospitals in the Metro Detroit area. And then you could do, for example, for the prostate cancer, image analysis. Right now, what we are doing using this collaborative learning, that a little bit different from federated learning here is to analyze all the data here that to help them to improve the real-time decisions, etc. The key here is the data stay where it is. Even within the same system, they don't want to move in the data, go to a centralized places. So that's a perfect place that we have to do something here. So what we have done is we deploy the edge node for each of these workers running on each of them, and then that you have a task. So you can have a central control node here, and then you can manage it here where to running on the things. So this was the original idea, Kate, that was mentioned when I proposed in that paper, collaborative edge. So we deploy the firework sort of is running here. It's basically the idea is to how do we leverage those different hardwares. Interesting thing here is, although it's in the same healthcare system, but what happened is they have a different hardware because the hardware was purchased during a different time. They have different software. They have different, they have a different format. There's a lot of challenges here. So that when you want to working on this collaborative, learning deploy here, you will run into a very interesting issues here, heterogeneity in terms of data, in terms of the, the hardware, and etc. I think I will stop here. So basically, I want to share with you that, edge intelligence era is here, and there's a lot of opportunities. You could work on different applications. You could work on the architecture, storage, and different things. But most important thing is you need a test bed here to run all these things. I think that hopefully through this workshop, and I if possible, we would love to start using the Kai and the Edge to run some experiments here. Yeah, thank you very much. So all the work I mentioned here available on our website. So that yeah, thank you.
Yeah. So Weisong, thank you. That was a fabulous keynote, and of course we hope that you will use G&Edge very much so. It's also interesting to think about OpenAI framework on G&Edge. I think that would be very cool for users to be able to use the appropriate machine learning methods appropriate for Edge. But I've got one question, since you seem to have a crystal ball. I wanted to ask you something. You referred to, I believe, a Gartner survey or Gartner predictions on how much data processing is going to be happening at edge. And people always bring up those numbers as an absolute statement. And what I think is very interesting is how much of that is going to shift from data centers to the edge, right? Because up until recently, all of it was located in the data center, where all the processing was located, and sort of started drifting to the edge. And I'm sure it's going to grow in data center, but on the edge, is it going to go faster?
Yeah, I'm glad you asked this. So that was from Gartner, and also my own experience with our vehicle side. There's I didn't share the slides here, but there is a estimation that the connected autonomous vehicle alone gonna contribute 17% of all the data gonna be generated.
Just the vehicles.
That's the vehicle, because you think about this. Each vehicle, I had a meeting before this workshop. I had a meeting with Toyota. So they are talking about Toyota alone have about how many vehicles is running there, and Toyota now is really need to find out the infrastructure to support them, because each individual Toyota vehicle needs to be connected to all this data, sending back to them and do the process. So that alone, there's an estimation from that that is 17%. So with that said, those numbers doesn't mean the data center is not increasing. Data center, you will continuously increasing, but at the same time, the edge generated data, and it will be increasing faster than that. I think that was the point here. We are not talking about the data shifting from data center to the edge. That's not the case. The data stay at the data center, will stay there, and you probably will be more data will be sending back. For example, those models and stuff will be still there, but at the same time, you can't. I can share with you one thing, that my student right now, you see for the fusion vehicle, we call the Hydra platform. We are so struggled in terms of this. If you have a LiDAR running there, and then you have 8 cameras, even the NVIDIA, the device we got from them, it costs like a $15K, that they don't have enough bandwidth to collecting to have all this data, coming at the same time. And this, if you continue running, that will be the continuously, the data there. I think that was why the Gartner is sort of that their prediction. Yeah. But I think data is just to keep going.
Yeah. Well, thank you for a fabulous talk. I see that there are no questions, though there are 2 very interesting comments on the chat. A request to everybody, if you have further questions for Weisong, please put them in the Q&A. We do need to move on to our next session, and I see that Jason is already there. So thank you very much again, and we hope to see you on ChiatEdge.
Sure. Thank you.
Thanks.
Yeah, I will stay here for a little bit in case there are some questions.